Allotropes of carbon. Allotropy. The property of an element to exist in two or more physical forms having similar chemical properties but different physical properties is called allotropy. Carbon forms two types of allotropes. 1. Amorphous form. Amorphous carbon is free, reactive carbon that has no crystalline structure. For example, coal, wood charcoal, petroleum coke. Crystalline form. Carbon atoms can arrange into different hybridized chemical bonds. Thus, they exhibit different physical and chemical structures such as diamond and graphite. Let us understand some crystalline structures in detail. Diamond. Diamond consists of covalent network structures with each carbon atom forming excited state sp3 hybridization. Shape of a diamond is tetrahedral with bond angle 109.5 degrees and bond length 1.54 angstrom. It is the hardest naturally occurring substance. Diamonds are used in jewelry and in stone polishing and cutting. Graphite. Graphite consists of covalent network structures with each carbon atom joined with three other atoms with covalent bond forming sp2 hybridization. These carbon atoms form a layer-like structure with a hexagonal arrangement of carbon atoms. Each carbon atom has one non-bonded electron is detached over the complete layer. These layers have weak forces between them. Due to these, the layers can slip over each very easily. The interaction between the layers are known as London dispersion forces with distance of 3.35 angstroms. Graphite is used as lead in pencils and lubricant, also used as anode in lithium-ion batteries. Buckminster Fullerene. Buckminster Fullerene is discovered by a team of scientists Robert F. Curl, Hallard W. Corto, and Richard E. Smalley in 1985. Buckminster Fullerene is spherical carbon allotropes where 60 atoms are assembled in 12 pentagons and 20 hexagons in geometry similar to a soccer ball. These are known as buckyballs and formed when vaporized carbon condenses in inert gas atmosphere. Buckminster Fullerene is used as antibiotics against the bacteria and cancer cells like melanoma. Nanotubes. Nanotubes are discovered in 1991 by Sumio Lee-Jima. Nanotubes consist of hexagonal arrays of covalently bonded carbon atoms rolled into cylinders. Nanotubes are good conductors of electricity, so they can be used as molecular wires as well as in integrated circuits.